तूफान मजा आती है बस शेयर मुझे भी गए असल अति बघायचं अति कैमरा बंद वही शेयर करना
आया चाहे ना
ना
गोसा सब लोग गिनना
ना यस ओके
चलो ठीक
ओके चला एका खाली म्हणजे पाणी पीपीटी
और सब पीपीटी शेयर है शेयर लेक्चर
ठीक है
नवासुब दयो यमो ये तजु दयो सिस्टम पर कोरमुत ये लॉग इन एक पर करू ते लॉग आउट जेन कोलगाम से ज आईडी खसाई पत गस इको हां करना ब एक्सपेल
काम काम
ओके हेलो जी जी बोलिए बोलिए हाँ जी जी बोलिए हाँ आ गए ए आर टी एस हाँ कर लिया मैंने आप ठीक हो गए ना आप ये आप हो गए ना इन यहाँ से तो मैंने कर लिया आपको आप मुझे दिख रहे हैं आप अपनी स्क्रीन में तो दिख रहे हैं आप मुझे जी हाँ हाँ यहाँ तो हो गए आप एक मिनट नहीं आवाज नहीं आ रही है अभी आप जरा बोलिए आप बोलिए मेरी आ रही है आपको आवाज नवासो ये
बस
सिस्टम
आसान
अगर बस एक्सपेल कर ना ये इनका ना दुश्मन एक्सपेल
आसान हेलो।
हाँ नवाज ये लो वीरेंद्र जी आप कर रहे हैं ये।
हाँ बिल्कुल। तो पता है आपका रिया साहब आप बंद बंद कर दीजिए मेरा या भैया साहब।
बोले आपने की थी अभी ये आपकी ये पीपीटी दिख रही थी लेकिन आपने फिर रिमूव की है शायद। आप दोबारा शेयर कीजिए पीपीटी आपने। हाँ नवाज साहब ये आपकी पीपीटी दिख रही है लेकिन इसको आप प्रेजेंटेशन मोड में चलाइए ना।
ठीक
नीचे वाले प्रेजेंटेशन मोड में चलाइए नीचे। हाँ एग्जैक्टली। कीजिए इसी पे क्लिक। इसी इसी आइकन पर कीजिए नीचे जो राइट आइकन है ना। हाँ नवाज साहब जो स्लाइड स्लाइड शो है ना नीचे नीचे वाला आइकन उसी पर आप इसी इसी पे कीजिए इसी पे क्लिक कीजिए इसी पे स्लाइड शो हाँ एग्जैक्टली। नहीं हो रहा है अभी भी नहीं हो रहा है ये। हाँ हो गया बिल्कुल। अब इसको मूव कीजिए आप। हाँ बस मूव ही हो रही है ठीक है। ठीक है। हाँ अब इसको प्लीज आप रिमूव कीजिए तो जो दूसरा पार्टिसिपेंट है वो भी अपनी पीपीटी शेयर करके उसका भी हम ट्राई ट्राई आप इसको रिमूव कीजिए प्लीज। ओके ओके थैंक यू थैंक यू।
पहले आ गया पहले आ गया गरम बहुत नहीं है ऐसा
हाँ, आवाज आ रही है, आपकी आवाज आ रही है। अरे सब आवाज आ रही है।
हाँ जी सर, अब आवाज आ रही है? आवाज भी आ रही है सर? आवाज आ रही है अभी?
हाँ, आपकी आवाज आ रही है, आपकी ये मूव भी हो रही है, आपकी पीपीटी दिख भी रही है।
ये स्लाइड्स मूव करके देखूं मैं?
हाँ हाँ, कर लीजिए प्लीज।
पैक करना होगा यहाँ
आवाज बैक
तो आवाज इतनी है
स्पीकर के लिए बोल रहा हूँ।
है ना आगे भी
मूव हो रही है?
मूव हो रही है इस पे रखना तो कंट्रोल
तो इसको भी देखना जरा, ये मूव हो रहा है?
अकाउंट पर को ऑफ कर ना ये। हाँ, हो
सर
रहा है,
ये
हो रहा है, ये मूव हो रहा है, ठीक है आपका, ठीक है ठीक है। हाँ, अब इसको प्लीज
लीड चल
रिमूव
रही
कीजिए,
है?
जब सर आएंगे तो जब आपको कहेंगे शेयर करना उस वक्त कीजिए।
ठीक
ये
है
ठीक चल रही है अब, इज फाइन
ठीक।
नाउ। ओके ओके, थैंक यू थैंक यू।
बस ये
तो शिफ्ट है ये इधर से
आपका पेज दिख रहा है? मैं
मुझे
ज्वाइन
कुछ
कर
पता
रहा
नहीं
हूँ।
चल रहा। कर ले इसी यार फोन ये रख ले अपना फोन।
साइलेंट कर देना।
देखना अबे हिंदी
हाँ
कॉल
जी,
है।
अगर क्या पता
अगर हिंदी कॉल आई ना
मतलब ना वो थोड़ा
एनआईटी मंगा रही है, एक मिनट, कौन सी फाइल हो गई है?
这个企业是一个类 Hello.
Good afternoon, sir. Good evening, sir.
Good evening, sir.
Yes, sir.
Well, what are the instructions
Yes, sir.
from ACS, sir? Should we start?
Yes,
or
sir.
we-
Yes, sir. You are audible. Yes, sir. I think, sir, we should start the first presentation.
So let us start. I'll request Deepak Khajuria, who is from RTIC. He will
Thank you, sir.
present his presentation on modernization of Ravi Canal. Have you shared your? Yeah,
So
PPT?
is the screen visible?
Start.
Should I go ahead? Am I
Yes,
audible?
yes. Yes, you are audible. Carry on.
Okay. Good evening, respected ACS sir, respected Chief Engineer sir, and to everyone who is attending this presentation. मेरा नाम दीपक खजुरिया है, and I am working as Assistant Engineer at Ravi Tavi Irrigation Department. Our department is currently working on a project titled as Improvement or Strengthening of Main Ravi Canal and its Distributaries, जिसमें हम अपनी existing canal network को restore और modernize करेंगे और साथ ही अपने distribution network में कुछ नए structures भी add करेंगे. इस प्रोजेक्ट की एस्टिमेटेड कॉस्ट 571.83 करोड़ है. इसकी बेनिफिट कॉस्ट रेशियो 2.40 है. ये प्रोजेक्ट हालांकि अभी अप्रूव नहीं हुआ है. इट इज एट द स्टेज ऑफ अपलोडिंग ऑन CWC's EPAMS पोर्टल. आज की इस प्रेजेंटेशन में हम इसी प्रोजेक्ट के बारे में चर्चा करेंगे और इस प्रोजेक्ट की अहमियत को समझेंगे. देखिए, रावी तवी इरिगेशन प्रोजेक्ट इज बेसिकली अ conglomeration of two canals, namely the main Ravi Canal and the main Tavi Lift Canal, which was envisaged for construction in early 70s. आप यहाँ पे जो देख रहे हैं, दिस इज मेन रावी कनाल. और अगर हम अपनी मेन रावी कनाल की ही बात करें तो ये कठुआ के बसंतपुर से लेकर विजयपुर के चक सलारियां तक फंक्शन कर रही है, विच वी कैन ब्रॉडली डिवाइड इट इनटू टू पार्ट्स. पहला हिस्सा बसंतपुर से लेकर उज बराज के लेफ्ट बैंक तक जाता है, जिसमें हमें जो पानी मिलता है वो 2 लिफ्ट स्कीम से मिलता है, लखनपुर लिफ्ट स्टेशन और बसंतपुर लिफ्ट स्टेशन। इन दोनों की रिस्पेक्टिव कैपेसिटीज 200 क्यूसेक्स और 500 क्यूसेक्स है। टोटल कैपेसिटी 700 क्यूसेक्स की होने के बावजूद ड्यू टू सम शॉर्टकमिंग्स ऑफ दीज लिफ्ट स्टेशंस हमें एमआरसी में केवल 300 से 350 का क्यूसेक्स का ही डिस्चार्ज मिल पाता है। दूसरा हिस्सा उज बराज के राइट बैंक से लेकर चक सलारियां तक जाता है, जिसमें हमें जो पानी मिलता है वो उज बराज से मिलता है, जो हमें अमूमन ऑन एन एवरेज 500 से 600 क्यूसेक्स का डिस्चार्ज दे देता है। हमारी इस मेन कनाल का डिजाइन डिस्चार्ज 1150 क्यूसेक्स है, जो कि हमें जल्दी ही शाहपुर कंडी डैम के कंप्लीट होने पर मिलने लगेगा। एंड टू प्रिपेयर अ कनाल टू efficiently carry and distribute this discharge, this is what our project is all about. Now have a look at some historical background of the Ravi Canal. देखिए, जनवरी 1955 में जो रावी के पानी को लेकर इंटरस्टेट एग्रीमेंट हुआ था, उसमें जेएनके को 0.69 एमएफ पानी एलोकेट किया गया था। बैलेंस 0.475 एमएफ पानी जेएनके को रावी कनाल के थ्रू रंजीत सागर डैम से मिलना था, जबकि 0.215 एमएफ पानी जेएनके करंटली कठुआ कनाल के थ्रू ले रहा है। अब रावी कनाल के थ्रू रंजीत सागर डैम से पानी लेने के लिए 1972 में रावी कनाल की कंस्ट्रक्शन का प्रोजेक्ट फॉर्मुलेट हुआ, जो 1973 में अप्रूव हुआ, एंड फाइनली इन 1975 द कंस्ट्रक्शन ऑफ कनाल बिगन। 1980 के आते आते हमारी कनाल नेटवर्क का 90% कंस्ट्रक्शन पार्ट कंप्लीट हो चुका था, और बसंतपुर से रंजीत सागर डैम तक इसे कनेक्ट करने के लिए हमें 3.25 किलोमीटर की टनलिंग की जरूरत थी। एंड देयर वर अ लार्ज स्ट्रेच जहां की हमें क्लोज कॉन्ड्यूइट्स भी बनाने थे। सो 1979 में जो इंटरस्टेट एग्रीमेंट हुआ जेएनके और पंजाब गवर्नमेंट के बीच, उसमें ये डिसाइड हुआ कि बजाय रावी कनाल को रंजीत सागर डैम से कनेक्ट करने के, इसे रंजीत सागर डैम से 7.5 किलोमीटर डाउनस्ट्रीम प्रपोज शाहपुर कंडी डैम से कनेक्ट किया जाए। इससे जो डिफिकल्ट स्ट्रेच था स्टार्टिंग का रावी कनाल का, उसे कंस्ट्रक्ट करने की भी जरूरत नहीं पड़ती, और साथ ही जो बैलेंस पोर्शन की लेंथ थी वो भी रिड्यूस होकर 1378 मीटर रह जाती। और इन एडिशन टू दिस, ये जो 1378 मीटर का स्ट्रेच था, ये भी शाहपुर कंडी डैम अथॉरिटी द्वारा ही बनाया जाना था। सो दिस प्रपोजल वाज वेल एक्सेप्टेड बाय द जेएनके गवर्नमेंट। पर उस समय जहां रावी कनाल के नेटवर्क का 90% हिस्सा कंप्लीट हो चुका था, उस समय ना तो रंजीत सागर डैम कंस्ट्रक्ट हुआ था, हुज कंस्ट्रक्शन बिगन इन 1981, और ना ही शाहपुर कंडी डैम, जो कि उस वक्त हाल ही में प्रपोज हुआ था, वो जल्दी कंस्ट्रक्ट होने वाला था। सो फॉर एन इंटरिम अरेंजमेंट, जेएनके गवर्नमेंट ने अपनी कनाल को फंक्शनल बनाने के लिए 2 लिफ्ट स्कीम्स तैयार की, लखनपुर लिफ्ट स्टेशन और बसंतपुर लिफ्ट स्टेशन, जो रावी कनाल को बसंतपुर से लेकर उज रिवर तक ऑपरेट करेगी, और उज रिवर से डाउनस्ट्रीम टिल द टेल एंड इसे ऑपरेट करने के लिए उज लेवल क्रॉसिंग भी कंस्ट्रक्ट की गई। सो दिस इज हाउ द रावी कनाल स्टार्टेड टू फंक्शन द वे इट इज फंक्शनिंग टुडे। Now have a look at this working diagram of the Ravi Canal. इसमें आप कुछ इंपॉर्टेंट फीचर्स जैसे मेन रावी कनाल, उज डैम, शाहपुर कंडी डैम जैसे फीचर्स देख सकते हैं। अगर हम यहाँ शाहपुर कंडी डैम की बात करें, इट इज गोइंग टू कंप्लीट इन 2000, यानी इसी साल ये कंप्लीट होने जा रहा है, और इसी के साथ ये जो बैलेंस पोर्शन है रावी कनाल का, विच इज 1.3 किलोमीटर्स, ये भी कंप्लीट हो जाएगा। अगर हम इसी बैलेंस पोर्शन की बात करें रावी कनाल की, विच इज 1.378 किलोमीटर्स टू बी प्रिसाइज, दिस इज बीइंग कंस्ट्रक्टेड बाय शाहपुर कंडी डैम अथॉरिटी एज पर द एग्रीमेंट साइंड बिटवीन द गवर्नमेंट ऑफ जेएनके एंड पंजाब. Almost 90% of the work has been completed and is expected to complete by June 2024 as stated by Shahpur Kandi Dam Authority. अब जरा देखिए 1975 जब रावी कनाल की कंस्ट्रक्शन शुरू हुई, एंड दिस इज 2024 जब ये फाइनली कंप्लीट होने जा रहा है पूरी तरह से. दिस इज ऑलमोस्ट 50 years of gap. Now have it look at these two pictures now. These two pictures basically represent the present condition of the main Ravi Canal and many of its distributaries. इन दोनों पिक्चर्स को हम देख के कह सकते हैं कि ये जो कनाल है, दिस इज ऑलमोस्ट अनफिट टू कैरी द थर्स्ट ऑफ 1150 क्यूसेक्स ऑफ डिस्चार्ज. पर ऐसा नहीं है कि ये कनाल जो है ये 1150 क्यूसेक्स का डिस्चार्ज नहीं झेल सकती. वी कैन ऑपरेट विद दिस मच ऑफ डिस्चार्ज एज वेल. पर दिक्कत ये है कि हमारे ये जो स्ट्रेच है इसमें बहुत सारी जगहों पे लीकेजेस हैं, जो कि डिस्चार्ज बढ़ाने पर वो लीकेजेस भी बढ़ेंगी. सो नेट रिजल्ट वही रहेगा कि टेल एंड पे जो फार्मर्स है वो फिर भी सफर करेंगे. So there are many existing deficiencies in the canal system Due to insufficient funding and subsequently lack of proper maintenance, canal system is in damaged condition over past several years. The distribution system particularly is in bad shape and have lost their design carrying capacity. Several structures and the canal lining have been damaged. Extensive growth of vegetation and plants is there inside the canal prism. There have been recurrent breaches and slips in several vulnerable embankment reaches. The deep cut reaches have suffered extensive damages due to slope slip, rock falls, collapsed lining, etc. So the net result is that there is a significant reduction in the irrigated area in comparison to the command area. Now have a look at this KML, जिसमें आप ये जो येलो रीजन देख रहे हैं, येलो एरिया देख रहे हैं, दिस रिप्रेजेंट्स द कल्टिवेबल कमांड एरिया ऑफ द मेन रावी कनाल नेटवर्क, और ये जो पिंक एरिया है, दिस इज रिप्रेजेंटिंग द CCA करंटली बीइंग इरिगेटेड. As you can see, the clear difference between the two figures is high, और इसी इरिगेशन डेफिशिएंसी या यूं कहे इरिगेशन रिक्वायरमेंट को पूरा करने के लिए हमारी कनाल की नेटवर्क को उसकी फुल पोटेंशियल पे हमारी कनाल को उसकी फुल पोटेंशियल पे चलना जरूरी है, एंड दिस इज वेयर द इंपॉर्टेंस ऑफ आवर मॉडर्नाइजेशन प्रोजेक्ट कम्स इन. Now these are some of the salient features of the Ravi Canal. Source of water is of course river Ravi. The type of canal is contour canal. आसान भाषा में कहूँ तो contour canal is that canal which traverses almost parallel to the contour lines. और इसी के कारण ये अपनी कोर्स का सिर्फ एक हिस्सा ही, यानी कि ओनली वन साइड ऑफ इट इज इरिगेटेड बाय दिस टाइप ऑफ कनाल. और अगर रावी कनाल की बात करें तो ये अपनी लेफ्ट साइड का हिस्सा इरिगेट करती है. कल्टिवेबल कमांड एरिया की अगर हम बात करें, विच इज 32,186 हेक्टेयर्स, विच मेक्स अप 79,500 एकर्स, with an irrigation intensity of 168%, which makes the ultimate irrigation potential equal to 54,072 hectares. One thing here I would like to point out is that ये जो CCA है, this is among the largest CCAs in the J&K Union Territory. The length of main canal, if you look at, is 79.8 kilometers. The length of distribution canal system is 520 kilometers. And mind you, this distribution network is the largest individual canal networks in whole Union Territory of J&K. The bed grade of canal is 1 in 3,300 meters. The design discharge is 1,150 cusecs. And again, 1,150 cusecs discharge is the highest among all the individual canals in J&K UT. So long things short, अगर हमारी ये जो रावी कनाल है ये अपने फुल पोटेंशियल पे चलती है, देन इट जो, और ये किस तरह चलेगी, व्हेन दिस मॉडर्नाइजेशन प्रोजेक्ट इज इम्प्लीमेंटेड एंड एग्जीक्यूटेड, देन ये जो रावी कनाल है विच इज इन डिग्रेडेड कंडीशन एट द मोमेंट, इट विल कम अप टू बी द लार्जेस्ट इरिगेशन प्रोजेक्ट इन द UT. Now have a look at some of the components of the modernization project. It can be broadly divided into the restoration part and the modernization part. अगर restoration की बात करें, we will cover the removal of silt, vegetation, bushes and plants within the canal prism area. We'll do the resectioning of canals and strengthening of banks, the mechanized placement of CC lining in vulnerable canal reaches, and providing protective CC lining on upstream and downstream of canal structures will be done. In addition, the repair and restoration of damaged canal structures will also be taken under, and along with that, the repair and replacement of the damaged mechanical gates and equipments will also be taken under the project. Now, taking the modernization part, in this part, we will cover the construction of canal siphon of 400 meters on Uj River, upstream of the level crossing, to ensure the continuity of flow in canal during the flood in river. The construction of additional distribution system of 10 kilometers to cover the left out or balance command area is also taken into account in the modernization project. And in addition, the motorized operation of gates to the optimum possible extent on important structures is also going to be implemented into the project. Now, this is a general abstract of the work. As you can see, out of the 79.8 kilometers of total length of the main Ravi Canal, we are taking up 37.55 kilometers of the length under modernization, and this covers mostly the filling stretch of the main Ravi Canal. Out of 46 siphons, we are taking 27 siphons under the modernization. 8 out of 9 aqueducts and 6 out of 10 escape gates are also taken under the project. In the distribution network, the total length of 520 kilometers, we are taking up 239.25 kilometers out of it for the modernization. And out of a total 730 other structures, we are covering 400. These are some salient features of the detailed project report. The districts covered under the project are Kathua and Samba. The tehsils that come under are Kathua, Marine, Hiranagar, Gagwal, Rajpura, Samba, Vijaypur, and Ramgarh. The project cost is rupees 571.83 crores. The benefit cost ratio is 2.40. Ultimate irrigation potential is, of course, 54,072 hectares, as mentioned earlier, and the beneficiaries are 7,544 families. Now, in the implementation of the project, there are some challenges as well. Let's have a look at the pre-approval challenges of the project first. See, the DPR involves CCA of 32,186 hectares and is characterized under a major project, and therefore requires to be submitted through EPAMS portal of the Central Water Commission. It will be the first DPR of J&K government in irrigation sector of this large amount that is to be submitted on EPAMS, which involves uploading of data with strict guidelines of CWC chapter wise, and to completely adhere each and every guideline of CWC with the resources available with the department is challenging. Now, there are some post-approval challenges as well regarding the project. Now, see, for the execution of the work in functional canal, there has been only 3 months working time available, which is the closure period. और अगर हम ये सोचें कि हम इस प्रोजेक्ट को इम्प्लीमेंट और एग्जीक्यूट इस क्लोजर पीरियड में करेंगे, इट विल टेक अ लॉट ऑफ टाइम. सो इंस्टेड ऑफ डिपेंडिंग ऑन जस्ट द क्लोजर पीरियड, हमें क्लोजर पीरियड के साथ साथ कुछ एक्स्ट्रा टाइम भी ढूंढना होगा, जो कि हम राबी सीजन में, जहां हमारे पास जो इरिगेशन वाटर की रिक्वायरमेंट होती है वो कम रहती है, वहां हम ये टाइम विंडो ढूंढ सकते हैं. This project needs to be completed in a minimum possible time in order to abstract the benefits of the project at an earliest. Therefore, funding of the project should be done accordingly. Now, here is a briefing of whatever we have discussed earlier. See, the project improvement and strengthening of main Ravi Canal and its distributaries is of utmost importance, and the canal network is spread in 2 districts irrigating the arid region, and it has a potential to irrigate a significantly larger area than it is irrigating presently. It took so long of a time to get the allocated share of Ravi water, and when it is at our doors, we should better be prepared to receive that share that belongs to us with both hands. Ravi Canal irrigation is among the largest irrigation networks in the Union Territory, and with the approval and execution of the project, it will be able to operate at its full potential, and then we could probably say, yes, we have provided har khet ko pani. Well, the presentation doesn't end here. There are some additional benefits of the project. One of them is saving in groundwater usage. See, ग्राउंड वाटर को अगर हम इरिगेशन पर्पस के लिए यूज करते हैं, वो भी तब जब हम ये पानी किसी अल्टरनेट सोर्स से प्रोवाइड कर सकते हैं, इट इज टोटली नॉट रीजनेबल. देखिए, ग्राउंड वाटर जो है वो एक लिमिटेड रिसोर्स है, और इरिगेशन के लिए इसे यूज करना, जहाँ पे पानी की रिक्वायरमेंट काफी ज्यादा रहती है, वहां अगर इसे हम ग्राउंड वाटर को यूज करते हैं, इट विल अल्टीमेटली रिजल्ट इन द डिप्लीशन ऑफ द ग्राउंड वाटर टेबल रैपिडली, and this is what is happening over the last few years especially. And if the Ravi Canal is able to take up the whole command area under the irrigation, it will not only irrigate the whole area, which is currently, many of the parts of which are currently using the groundwater, it will also replenish the groundwater table along with the reduction in groundwater usage. There may be some other uses of the project as well, but for now we will be ending our presentation here only. If you have any questions regarding this presentation, regarding any data that we have presented, me and my colleague Sandeep Koshal are here. We will try to answer that. Any questions regarding any of the data, any project relating questions, you may proceed. Anyone with any question regarding the presentation? Am I audible?
Yes, yes.
Yes, I have a question. I'm Shakil, Executive Engineer, PhD, Badgam.
Hello, sir. Good evening.
Good evening. When you were preparing when you conduct the survey and the preparation of DPR, had you hired some consultants for the same?
Consultants?
Yeah.
No.
It was all inbuilt by the department itself, all the surveys conducted by the department itself?
Yes, sir. Only the department personnel engaged in this, sir.
Okay.
We have not
Now,
consulted any
my
consultants.
question is, are there any measures put in place for measuring the discharge of the canal at any point of time?
Sorry, I couldn't get the question. Can you please
Are
repeat,
there
sir?
any measures put in place for measuring the discharge of the canal? And what is the velocity when you have a 1 in 3,300 meter bed slope?
So the velocity we are having is almost 1.3 meter per second, sir. 1.3 meter per second, sir.
Discharge of the canal at any given point of time?
So we so measuring the discharge and adding it. No, sir. We have only
just the gauges.
we are only dealing with, sir, the old traditional methods. The gauges have been installed at many places. Accordingly, we are getting the discharge from that, sir.
Oh,
We are getting the discharge from the gauges we have in the canal, sir.
Yes, I am repeating
Sir.
the North Circle, Srinagar. Previously, this project was named as the Ravi irrigation. That the name has been Tavi has been deleted from the project. Now it is only now the Ravi Canal.
Sir, please repeat the question, sir. We not getting your voice, sir.
Previously, the name of the project was the Ravi Canal. Now you are mentioning only the Ravi Canal. Whether the name has been changed to the only Ravi Canal and deleting the Ravi?
No. The Ravi Canal, basically the project is regarding the Ravi Canal only, and Tavi is nowhere deleted from the project. And also, when we execute the project, the 19,500 acres of the command area of Tavi is also taken into account in this project. So it is not deleted actually.
So the project is only related to the share of water we are getting from the Ravi River, sir.
Yes.
So Tavi is
So the project name is still the Ravi irrigation.
yes, sir. It is same, sir.
So you talked about you have talked about the problem which are arising for the Ravi Canal, and what will be the execution and how will the proper execution of this project will take place?
So please, sir, please repeat. Actually, the voice is not that much audible, sir.
Good evening, sir. Sir, this is Rishabh from Subdivision Aknur. Sir, my question is, you have talked about the problems regarding the existing canal and talked about the future idea of that canal. I just want to ask you what will be the possible outcomes and how will be the execution of this project will take place? What will be the idea for the execution, sir?
ID for execution.
एग्जीक्यूशन की अगर हम बात करें तो इसमें एज आई हैव आल्सो मेंशनड इन द स्लाइड्स टू कि we'll prefer going with the mechanized placement of the CC lining, and that will actually rapid up the work. And other than that, इसके अलावा आपने क्या पूछा?
And we are also trying that this project, when will get implemented, we'll try to complete it within a 3 or 4 years, so
Yes.
that we get whatever benefits that we are expecting to get, we get in an earliest stage.
Earliest possible time.
ये ऐसा नहीं होना चाहिए कि इस प्रोजेक्ट की फंडिंग 10 या 15 साल तक चले, तो उस मतलब हम वैसा नहीं रहना चाहिए कि 10-15 साल हम फिर से उस पानी के लिए वेट करते रहें. जैसा भी रहा, मैं हमारा मैक्सिमम कोशिश यही है कि विदिन 4 or 5 years we'll complete it in any way.
Sir, it's not about time period. I'm talking about the proper execution of your work, sir. How will be the proper execution of your work? Your idea will be implemented on the ground level, sir.
ग्राउंड लेवल पे किस तरह से काम
Execute
होगा, तो एग्जीक्यूशन के लिए वी हैव लाइक एक्सपीरियंस स्टाफ एज वेल. एग्जीक्यूशन में अगर कंपोनेंट्स की बात करें तो यहाँ पे सीसी लाइनिंग का काम रहेगा, जैसे हमें लाइनिंग बनानी है कनाल की, देयर विल बी एट प्लेसेस 2 वॉल्स विल बी कंस्ट्रक्टेड अकॉर्डिंगली यहाँ पे रिक्वायरमेंट होगी, एंड वेरियस स्ट्रक्चर्स लाइक साइफन्स एंड aqueducts and other structures will also be taken under, or the works will be allotted to the contractors, and as stage contractors नहीं होंगे,
but large scale contract.
yes, the contractors will take up the work and we will be supervising the work as well. So this is a basically execution procedure that is remaining the same throughout the project, but yes, we will be preferring going with the mechanical equipments for the CC lining, especially because that will considerably reduce the time of execution. So this is whole idea, brief idea about the execution procedure of the project.
Sir, the problem you told about that previously the canals were not properly, washed or cleaned or not executed properly. My question is, you talked about the problems. I'm talking about the possible solutions, how you will, make it sure that these canals will be in the proper channelized way. My question is, you talked about the problem. I'm talking about the solutions, proper solution in a mechanism way.
First of all, actually, we have not just talked about the problem, we have also talked about the solution. That is what the project is about. But anyways, implementing the project, of course, is a long procedure basically. And it is not just about execution, it is also about the maintenance onwards. So we have staff for that, just like as I mentioned earlier, for the execution part, how will be going on, and rest remains about the watch and ward. So the maintenance, as we do at the present, the maintenance will be done likewise, जैसे कि अब अभी करते हैं. We have staff for that. We have the funding as well.
So the thing is, if you're talking about the maintenance part, so maintenance to sir abhi bhi existingly bhi chali rahi hai sir. How can you make sure that the maintenance will be in a proper way, sir? Maintenance तो आज भी सर irrigation canals का चल ही रहा है सर. Discharge तो सर सही हालत तो सर अगर problem raise कर रहे हो तो problem तो सर वही persisting ही है सर. तो आप
एक्चुअली इसका क्या है, जैसे हमारा पुराना जो अभी जैसे हमारा नेटवर्क चल रहा था, अभी हम सिर्फ 320 और 400 और 600 क्यूसेक वाटर यूज कर रहे हैं. अकॉर्डिंगली हमारा जो मेंटेनेंस अभी हो रहा है, हम उसी को लेके चल रहे हैं, 600 क्यूसेक को लेके ही. फ्यूचर में जब 1150 आ रहा है, हमारा मेंटेनेंस भी अकॉर्डिंगली उसी तरीके से होगा. अभी प्रॉब्लम यही था कि हमारे पास इतना सफिशिएंट डिस्चार्ज ही नहीं है. तो डिस्चार्ज कम है तो हमारे पास जो फंड्स होते हैं वो लिमिट्स होते हैं, तो हम उसकी मैक्सिमम यूटिलाइजेशन इंश्योर करते हैं. इसलिए हम काम भी उसी हिसाब से करते हैं. जब हमारे पास पानी ज़्यादा होगा तो वी डू द वर्क अकॉर्डिंगली. तो दैट इज नॉट द केस कि हमें प्रॉब्लम आएगा. वी विल कॉप इट दैट.
ठीक है सर, थैंक यू सर, बट द सॉल्यूशंस यू टॉक्ड अबाउट वाज नॉट सैटिस्फाइड, बट ठीक है, थैंक यू सो मच सर.
Excuse me. Hello.
Hello.
Am I audible?
Yes, sir.
This is Anil Gupta, Executive Engineer, PHE City 2.
Good evening, sir.
Good evening. Yeah, I have a small query. One was just for this thing, because as we all know, Indus Water Treaty and this thing. So is there, I mean, that thing has been taken care of? Because if we get some problem on that account also.
See, that talking about Indus Water Treaty, it deals with just the river water. Ravi water is basically what we have the right to use, and along with that, there is this interstate agreement in which we have a fixed share that we have to take care of. So that share, that interstate agreement that has been done, that also takes already into account this Indus Water Treaty.
And so moreover sir, Ravi, Beas and Satluj, we India have to use that water sir, for Ravi,
Yeah.
Beas and Satluj.
Okay.
All share we India have to use sir.
One more supplementary question, actually. How much impact it's, I mean, whether that has been quantified, how much impact this project is going to make on economy of this J&K UT? Because with service, the growth and what you call the crops and this thing, because we are lagging behind, we are importing so much for everything. So, I mean, whether that has been quantified, how much impact, how much use actually in terms of what you call rupees, or how, I mean, how it's going to affect the economy of the state, UT.
See, See, the benefit cost ratio of the project is already calculated as 2.40 on the basis of this crop production as well. So crop production, if there is increasing significantly, as you can see from the benefit cost ratio, so it is of course incrementing in the economy of the union territory as well. But for the detailed calculations that we can share, but it is a lengthy calculation, so we will not be able to give the details of that right now.
And sir, net irrigation benefits that annually we are getting is 171 crore, sir. Net irrigation benefits. So it's a huge, sir. 171 crore. That's a irrigation.
मेरी एक सुजेशन रहेगी, मैं एससी रजौरी बोल रहा हूँ।
Yes, sir.
जी सर।
बाकी तो बहुत अच्छा आपका प्रोजेक्ट है, और जैसे जे शाहपुर कंडी से पानी हमें बाई ग्रेविटी मिलेगा तो ये इलाके की बेहतरी के लिए बेहतरीन है। लेकिन जो मेरा सर्विस एक्सपीरियंस है वो मैं थोड़ा सा स्ट्रेस करना चाहता हूँ। तो आई मे बी रॉन्ग और आई मे बी राइट, बट मेरी सुजेशन को सुना जाए। उसमें ये रहा कि इसका जो भी है कि ग्लोबल टेंडर किया जाए, क्योंकि जब हम इन पार्ट्स टेंडरिंग करेंगे तो कोई कंट्रैक्टर ऐसा भी आएगा जो काम अच्छा नहीं करेगा, वो उसका प्रॉपर ग्रेड नहीं मेंटेन करेगा, और कोई ऐसा आएगा जो काम छोड़ के भाग जाएगा। तो अदरवाइज जो इतना अच्छा वेल प्लान प्रोजेक्ट आप लोगों ने बनाया है, उसका फेट मेरे हिसाब से वो फेलियर की तरफ जाएगा। मेरी ये सुजेशन रहेगी कि जब भी इसको टेंडरिंग एग्जीक्यूशन की स्टेज में आए तो इसका ग्लोबल टेंडर लगाया जाए और एक ही फर्म आए, ताकि वो एक अकाउंटेबल भी होगी और एक साइड से वो काम करता करता आगे बढ़ता जाए। ये नहीं है कि 50 जगह से वो काम शुरू करेगा। तो जैसे हमारी पुरानी कैनाल का फेट आज खराब हुआ है, ऐसे ही इसका ना हो जाए। मेरा ये सुजेशन है।
Yes, sir.
बिल्कुल सर, दिस इज अ ब्यूटीफुल सजेशन एक्चुअली।
हेलो,
Hello.
आपने अपने इसमें अपनी प्रेजेंटेशन में कहा कि जो हमारी ये कैनाल की लेंथ है ये 97 किलोमीटर है और उसमें से आप 37 के लिए ये प्रोजेक्ट बना रहे हैं। तो
हाँ जी।
अगर ऐसा है तो फिर आपने एक बात और भी कही थी कि इसमें लीकेजेस जो है काफी जगहों पे हैं। जब हम पानी की कैपेसिटी बढ़ाएंगे तो वो लीकेजेस से फिर हम उसी नतीजे पे पहुंचेंगे। तो वो जो बाकी वाली लीकेजेस है उसके लिए भी प्लान है इसमें कुछ?
सर, हम जो ये 37.55 किलोमीटर का स्ट्रेच ले रहे हैं, दिस इज बेसिकली मोस्टली कवरिंग द फिलिंग सेक्शन जहाँ पे लीकेजेस रहती हैं, और कटिंग सेक्शन जो भी हमने स्ट्रेच छोड़ा है वो मोस्टली कटिंग सेक्शन में है, और वहाँ पे लीकेजेस उतनी ज़्यादा है भी नहीं, और जो हैं भी तो वो भी पानी के डिस्चार्ज को उतना घटाएंगी नहीं। तो फॉर द टाइम बीइंग हम अगर 37.55 किलोमीटर्स को लेके चले कवरिंग ऑल दिस फिलिंग स्ट्रेच, then also we will be getting the most out of it.
And moreover, from the last year we have executed some works that also we are covering in that, ना जो काम हमने किया है हमने उसको इसमें एक्सक्लूड कर दिया है।
एक टर्म आपने बीच में यूज की है, इरिगेशन इंटेंसिटी जो है आपने बताया है 100% है।
168%, yes.
हाँ, तो वो उसका क्या मतलब है 168% का?
सर, जैसे ये कमांड एरिया हो गया, उसके ऊपर जैसे खरीफ सीजन हो गया, उसमें हम कितने % एरिया में फसल उगा रहे हैं। तो जैसे इस प्रोजेक्ट की अगर मैं बात करूं, देयर इज 68% ऑफ द एरिया कवर्ड अंडर इरिगेशन एंड क्रॉपिंग इन द खरीफ सीजन, and 100% in the Rabi season. So total area that covers under the cropping or irrigation in the throughout the year comes out to be 100% plus 68%, which is equal to 168%.
Hello, am I audible?
बिल्कुल सर, yes, you are audible, sir.
Yes, I am retired SC. Now presently I am working as DPM of Kulgam. May I know how you will maintain in the silting area? You have mentioned there that there are mostly silting areas. How you are maintaining that? What type of treatment you are giving there?
Sir, as we stated that after commission of Shahpur Kanti we are getting, sir, from the dam what we better get is almost, sir, वो silt free रहता है almost थोड़ा सा। We are getting the ponding water, sir. उसमें वो थोड़ा सा silt free रहेगा तो silt हमारा वैसे भी कम हो जाएगा, sir.
Not silt, I mean silting area. Silting area.
So what, sir?
Silting area. You have
Slip
some
area, sir.
silting area. Yes, yes.
सर फॉर स्लिप एक्चुअली द जहाँ पर कैनाल हमारा सर डीप कट में है सर, वहाँ हमारा स्लिप होता है सर काफी। तो उसको
How you
काउंटरैक्ट
will
करने के
treat
लिए
that?
सर हमने ब्रेस्ट वॉल भी प्रपोज किया है हमने सर ब्रेस्ट वॉल काफी पार्ट्स में हमने प्रपोज की है इस कैनाल में सर, टू कवर वो स्लिप को कवर करने के लिए सर.
My suggestion is take geotechnology also into consideration,
Yes,
geo
sir.
bags and etc.
Yes,
That's
sir.
all. That is all.
Thank you for your valuable suggestion, sir.
Thank you very much, sir.
Thank you.
Any other questions from anyone?
I would like to say one thing, Deepak. You must bring out here the requirement of uploading this on ePAMS portal created by CWC for clearance of the DPRs. And I think this will be the first project of UT of J&K, which will be uploaded on this portal for clearance. You must bring out to the, for the information of all participants, because this is a new thing. Please.
Bring out what?
Okay, sir. No. We'll do that, sir.
आप बताएं इसको थोड़ा सा एक्सप्लेन करें सबके कि कैसे है ये ePAMS पोर्टल क्या है.
EPAM portals.
Sir, EPAMS का actually जैसे EPAM stands for the Project Appraisal Management. So it has been started by the Central Water Commission and it start working from 2020, sir. And from 2020 for this, the project authority needs to generate first is user ID and the password from the Central Water Commission headquarters New Delhi, for which we have to mail them and they give us the user ID and the password. Then over there is a portal, sir. We have to upload over DPR in it, sir, with a chapter wise, sir. It involves many steps, sir. Every step has a very deep involves a very deep knowledge of a project, and that's why we are facing a little bit challenging, but we will do that, sir. Sir, next, just
हेलो
Hello.
सुनाई दे रहा हूँ. हेलो.
Yes, sir.
हाँ, मेरा एक क्वेश्चन है. मैं सुंदर सिंह बोल रहा हूँ AWE बिलावर से. ये चीज ये जो आपने अभी मेंशन किया कि आपके पास वर्किंग सीजन सिर्फ 3 महीने ही रहेगा.
हाँ जी सर.
आप जब इस प्रोजेक्ट पे काम करोगे आपके पास 3 महीने ही रहेंगे जब नहर में पानी नहीं चलता है. तो उन 3 महीनों में आप इतना बड़ा प्रोजेक्ट कैसे मैनेज कर सकोगे? क्या इसके लिए कोई आपने रोड मैप बनाया हुआ है?
Actually, we are not covering it just in one closure period, but we will be trying to complete it at the most 3 or 4 years. So closure period को भी काउंट किया जाएगा, यानी कि 3 महीने into 4, 12 months हमारे पास ये तो रहेंगे ही. साथ ही मैंने ये भी कहा इसमें कि we will be finding some other time windows as well. राबी सीजन में कोशिश करेंगे कि जब रिक्वायरमेंट कम रहेगी पानी की, जहाँ नहीं होगी जरूरत, we'll be taking some portions of the canal accordingly.
Okay.
Hello.
Hello.
Good afternoon.
Very good afternoon, sir.
I am Acting Master Plan, PHE Srinagar.
Good afternoon, sir.
Usually, an average velocity in the irrigation canals is 0.6 to 0.9 meters per second. Just now, you are saying that you have taken a velocity of 1.3 meters per second. Have the covering of the bed taken into account? Has it been taken into account for?
Yes, sir. It has been taken into the consideration, and so what I want to make a point is, sir, this Ravi Canal is totally a lined canal, sir. It has a 10 centimeter thick PCC lining, sir.
Okay.
Yes,
Thank you.
Thank you, Deepak. Thanks for the nice presentation. Now we may go to the next presentation from Nawaz Ahmed Bhatt, Executive Engineer, PHE Kulgam.
Okay, thank you, sir. And thanks for
Thank
joining, everyone.
Nawaz Saab, you please start your presentation now. Nawaz Saab, please go to that full slide view. Full slide view.
अभी ठीक आ रही है?
Yes. अब ठीक है.
To all the participants and the staff chair, I, Nawaz Ahmed Bhatt, Executive Engineer, Jal Shakti Kulgam, is going to present
presentation on planning and designing of the water supply scheme. The basic objective of planning of the water supply scheme is that supply safe and wholesome water to the consumers.
Nawaz sir, your voice is not that clear. Please go nearer to your system.
Basic objective of planning is to provide to supply safe and wholesome water to the consumers, to supply water in adequate quantity and to make water available with easy reach to the consumers so that there is general cleanliness.
सर थोड़ा आहिस्ता बोलिए और इसके कंप्यूटर के पास जाइए कि आपको थोड़ा वैल्यू बढ़ा दीजिए। Not that clear.
Is it sir? I'm not audible, sir.
हाँ audible है लेकिन थोड़ा आहिस्ता आहिस्ता बोलिए।
Okay, sir.
So it should listen also.
The planning of a water supply scheme, sir, depends on these factors where we should have a source, then the quantity, that is the quantum of the water that is required, the quality of the raw water, the rate of consumption of the water, the topography of the area, and the future demands. These are the main factors that govern our water supply scheme, that govern the planning as well as the design of the water supply scheme. Out of these various factors, we are having two factors, that's the source and the topography, that govern the type of scheme that we should plan. If we are having a sufficient quantum of water available and we are having topography favorable, so that we can maintain the functionality requirement of the consumers, that we can maintain a requisite pressure, which as per the CPHU guidelines is 7 meters for a single story building. So we can go then for a gravity scheme. However, if we are having the source available, but the topography is such that the water can't flow by gravity from our source to our end users, then we have to go for lift scheme. So these two sources are mainly responsible for selecting the type of a scheme. Whereas the factors like quantity, rate of consumption, and future demands would give us the design of the pipe, how much big our scheme should be. That is the diameter of the pipe. In rural areas, we are having small hamlets, usually 300 households, 400 households, or at max 600 households. So the design of pipes would be accordingly like that. Mostly it goes to 150 mm to 200 mm, and in case it is a multi-layer scheme, it can go up to 300 mm, not more than 300 mm. Then the quality of the raw water. The quality of the raw water would give us the type of treatment that we should adopt. If we have to go for an aeration, if there is smell or if there is an odor in the raw water, then we have to go first for the aeration. Or should we go for a slow sand filtration if the turbidity is less than 20 NTU, if it is more than 20 NTU? So the type of treatment, should we consider a slow stand with the sedimentation or sedimentation with the rapid mixing? So this comes under the quality of the raw water. The quality of the raw water would give us the type of treatment that we should adapt for an efficient and for a robust water supply scheme. The source that is selected for a scheme should be free from all the encumbrances like riparian rights, because mostly it has been found that when we plan any water supply scheme, then during the execution phase, it comes to know that it has a riparian issue. So to avoid unnecessary litigations, we have to first rekey whole area and see what the source, is it suitable for the scheme or not, because as per the doctrine of the natural flow, we can't seize the rights of the riparian of the people who are on the riparian lands. Similarly, the source which is tapped at a particular location, that's our intake works, that should have suitable discharge. So that comes from the inputs of the local people who are having more knowledge about the source, because not only the springs, but in the nalas also there is variation in the discharge during the period in a year. In a source, scheme shall be efficient, the scheme shall be economical, as long as it has the water available in it. However, it has been found that in big sources also, during the lean discharge period, that is during the time of September, October, and November, discharge comes drastically reduced. So in that case, we have to see where our head work should be, because the hydrology of the Nala sometimes is such that if there is a flow flowing in a Nala, then it disappears, and then it appears some other location. Then we usually in rural areas, we then resort to extension of heads. That's a costly affair. So selecting a source and selecting a particular point for our intake works should be checked first, and the local community, local populace can give a valuable inputs about it. In fact, the JGM guidelines clearly mentioned in chapter 3 that GPS and the rural communities have planned, implement, and manage these water supply schemes. In all the water supply schemes that we have conceived under the JJ program, the source and alignment of the pipes, these two, we have taken inputs from the local population, and then we have incorporated that in our DPR. Planning of the siting and location of the structures. So this infrastructure that is needed for a particular water supply scheme, that is the filtration plant, the sedimentation tanks, the storage reservoirs, that would solely depend upon various factors, out of which topography plays an important role. It's the topography that would govern where our filtration plant should be, where our storage structure should be. So should my filtration plant and the service reservoir located more towards the source, or should it be located more towards the population, or should it in between? That all depends upon the topography of the area. So for an efficient water supply scheme, we have to calculate the exact location of these two important infrastructure units of the water supply scheme. If it is located too much towards the source, then in that case, the water that is drawing from the pipes towards the community, we know that for all those pipe network that comes from the SR, that is to be designed not only on the value of the Q, that is the water requirement, but on the value of Q multiplied by the peak factor. And that peak factor, as per the CPHEO manual, is 3 for a small water supply scheme, as well as for the schemes having the population less than 50,000. So the discharge is more. That means if my structure is located more towards the source, so my diameter of the pipe would be more. That means the cost of the scheme would get increased. Similarly, if my structures are located more towards the habitation, that means I have to recalculate whether my functional requirement of the scheme, that is maintaining the requisite pressure at the consumer end, which is 7 meters for a single story and 12 meters for a double story, is maintained or not. That way we have to calculate, and we have to recalculate and recheck and see all these factors. This is a typical layout of a gravity scheme and a lift scheme. We are having a treatment facility, then storage structure in a gravity scheme, and in a lift scheme also we are having this. So this has been elaborated in this. We are having a Nala or a river, then there is a treatment facility, then there is a storage structure. So the distance from Nala to treatment is L1, and the treatment to storage is L2, and storage to the community is L3. So for proper planning, for efficient functioning of a water supply scheme, all these values L1, L2, and L3 should be so chosen that we are having an efficient water supply scheme. We are having some design criteria available with us that govern these lengths. For example, for L3, the CPHU says that we should have a hydraulic grade line of 1 to 4 per 1,000. This hydraulic grade line, you can see on the left hand side, it is the summation of all those points which are below the energy line, minus velocity head, and minus the head loss in the pipes. So here I have simple calculation that the head loss in the pipes, it is a famous formula that we are using, and through which we calculate the diameter of the pipes. It is L times Q by CR. CR is a coefficient which depends on the material of the pipe, and then there is diameter of the pipe. So the head loss is inversely proportional to almost D to the raised power 5. That means as per our CPHU manual, HF plus velocity head should be 1/1000 to 4/1000. So L3 you can fix in that way. I'm having a map of the Kulgam available so that we can get a picture into. Okay, that has gone. The slope of the profile of the natural surface was 1 in 70. So let us take a typical example that we have done here also in Kulgam. We are having an RSFP and we are having an RCCSR. So RCCSR usually the depth varies from 3.5 to 4 meters, and then RSFP. So for having a constant surveillance on all my water supply infrastructure, it is better that I would construct RSFP and SR just nearer to one another. That means my L2 may vary from just 10 feet, 20 feet, or at max 30 feet. So the water that would be coming from the RSFP would be at a depth, at a height of 0.6 to 0.9 meters from the natural surface level. And that natural surface, that level at which the water comes out from my RSFP should form my top level of the SR. So when the SR is 4 meters deep and the natural profile is 1 in 70, so the supply line that we have to lay from the SR would involve excessive excavations. When these excavations are done for a considerable length, they are sometimes met with some other problem. Like if there is some nearby canal or some water table is near to it, then there may be dewatering problem. So we have to resort to heavy motors for dewatering. Then or we have to go for close timbering. In other words, locating RSFP and locating SR close to one another is having this difficulty. So we can shift our SR more towards our habitation, but that should be recalculated and rechecked with the pressure requirement. So the pressure requirement that at the consumer end should be a minimum of, that's the level difference minus pressure requirement consumer end minus head loss divided by slope of this line. So minimum value of the L4 here comes to 80 meters. So it is a steeper slope. It can be more, it can be less, but there are the construction difficulties. In other words, this gives just an insight into how we can locate and how the topography affects the location of our infrastructure. Then comes the quantity of the water. The quantity of the water that's required for a particular water supply scheme as per the JGM guidelines, or we are having 55 LPCD. The CPHU manual gives the LPCD criteria for the towns, for cities, and for metropolitans as 70, 135, and 150. Plus, there are some institutional needs that have to be added to our total water requirement. There is one more water requirement that we have to count and we have to add in the design of our water supply scheme is the firefighting. So firefighting, it plays an important role in case of towns and in case of cities. As per the CPHU manual, we have to have a provision of firefighting water requirement. So a population of 50,000, CPHU says that we should have almost 70 kiloliters of water should go for the firefighting. And out of this 70 kiloliters, that's almost 1.5 lakh gallons, 1/3 of it should be our dedicated supply. That is 1/3 of it should be available in our SRs all the time. So this water demand plus the demand of domestic demand plus institutional demand, that all give us the total value of the water that would be required for a water supply scheme. These are the institutional demands that are required for the designing of water supply schemes, whereas hotels, hostels, nursing homes. However, in case of rural areas, we don't have, we may be having some wellness centers, Anganwadi centers, those won't be having so much amount of the water requirement. Then comes next, that's a pressure requirement. So at the consumer end, we should have a pressure requirement of CPHU says 77 meters for single story building, then 12 meters for a double story, then 17 meters for 3-story building. The various design period that ought to be adapted in the planning and designing of a water supply scheme on or like this way. We are having 50 liters, 50 years for storage, that is for infiltration 30. We are almost having 30 years everywhere except electromechanical and pumps we are having 15, and water treatment we are having 15. The cracks behind this is that we can add another motor or a pump after 15 years. We can add another water treatment plant after 15 years, but it will be very difficult for us to lay a separate raw water, to lay a separate distribution line after 15 years. So all the lines should be designed for 30 years time, and pump houses should be for 30 years, and electric motors 15 years. Then comes the transmission of the water. In the planning and the designing of a water supply scheme, we can transmit the water either in the open channel or in the pressure conduit. Mostly open channel flow, we are restricting it to the intake works only, say up to a length of 100 feet or 200 feet. But the pressure conduits are mainly they are the mainly which we are using in our water supply scheme. Pipes are the main, that is the pressure conduits which we are using for transmitting the water. The pipe material, selection of pipe material is another important factor that is to be taken into account for the water supply schemes. So the pipe material would be having some value of the CR, that is the coefficient of the roughness. For CIDI pipes, it is 1 when it is new. However, it reduces to only 0.85 when the design period is 30 years. So selection of pipe material depends on durability, lifespan, installation, laying, jointing, and choice of the pipe material. In fact, the CPHU manual gives us a detailed account how we can select a particular pipe. There are which gives us marks from 1 to 10 for durability, for lifespan. We have to give numbers from 1 to 10. Then the pipe which is we having the highest number of, we can select it. But we are mostly having factors that govern these pipes are internal roughness, life and durability, operation. DI pipes we are mostly using in our water supply scheme. They are used because there is easiness in jointing, in flexibility, as well as in negotiating the curves, which is not possible in case of other material like GI material or CI material. In CI material, the jointing is almost extremely difficult. Likewise, in case of the GI pipes, the jointing is difficult. Also, with the flanges, we can somehow achieve the progress, but still the jointing is difficult, especially in negotiating the curves. So the DI pipes are designed as K7, K8, and K9, depending upon the thickness and depending upon the pressure they can handle. K7 pipes can handle a pressure up to 0.6 MPa, K8 up to 1.8, and K9 up to 1.8 megapascal. That means if we convert these pressures into the heads of the water, K7 can resist a head of 60 meters, K8 can resist 120 meters, and K9 180 meters. So all the water supply schemes should be checked whether they can resist this much pressure. If they can't resist this much pressure, when we close the values, then there should be some arrangement of safety values, so that when our main sluice is closed, the safety value gets operated. Otherwise, the pressure will get exceeded and there will be problems in the pipeline, especially those pipes which are having large lengths and which are having large lengths and higher level difference between the source and between the treatment plant. Or else we can have this pressure. We can put our pipe within this pressure by resorting to break pressure chambers. We can break that pressure at a particular location. A concrete box we can make so that the water is open to the atmosphere, and then it will start again going in the pipes. We are having the two types of joints that we are using in DI pipes and CI pipes. In DI pipes, we are having a push-on joint and lead. In CI pipes, we are having lead caulking joints. Mostly the DI pipes, they are very flexible. They are easy to negotiate in curves. We are using that there is no skilled labor involved in jointing these, whereas there is much more skill needed for these CI pipes. So you can see that in DI pipes we are having ease in the deflection. 5-degree ease, that means we can negotiate the curves. That's not possible in case of the GI pipes or in case of CI pipes. Plus, we are having much more, we can achieve more progress in DI pipes. Then comes the pipe design. The pipe design, that means determining the diameter of a pipe. So that is defined by a formula, that's the Hazen-Williams formula. So we are having the head loss in a pipe. We know we are having two fixed points. We are having the source available. We are having our habitation or village available. In between, we know where to locate our structure. That's where to locate the filtration plant and where to locate our SR. So based on that data, we can calculate the head loss in a particular pipe. So based on that head loss, we can calculate actually we have to assume some value of the diameter. Then we can calculate the HN, and based on that, we can calculate the pipe diameter for whole water supply scheme. Plus, CPHU manual gives us that for raw water main, we should have a minimum velocity of 0.6 meters so that we may avoid deposition or corrosion that may result in deteriorating the quality. Then comes design of the distribution network. So the distribution, once we are having filtration plant SR in place, and we have to design the pipes that are downside the storage reservoir. So all those pipes which are laid from storage reservoir after the filtration plant, they should be designed not only for the value of the Q, that value of the water that is good, but should be designed for a peak factor. That means the discharge in those pipes would be the discharge multiplied by the peak flow or peak factor. That you can see that for operation less than 50,000, we are having peak flow of 3, then 50 to 2 lakh, 2.5, and so on. For small water supply scheme, we are having a peak flow of 3. Then comes the water treatment. So water treatment is the aim of the water treatment is to produce and maintain water that is hygienically safe, aesthetically attractive, and palatable in an economic manner. The treatments that we adapt are aeration, sedimentation, rapid mixing, slow filtration, rapid filtration, and chlorination. The CPHO manual gives us a restore that we should resort to in selecting the type of the treatment for a particular type of water supply. So if we are having the turbidity less, we can directly go for 1 and 10. That is, we can directly go for storage and then chlorination and then supply the water. If it is groundwater, mostly in valley, we are having directly 10. That is, we don't go for any filtration. We don't go for any. We take the water from the tube well and then we store it and then we supply it. However, then carrying the problem is then we have to go for aeration or we have to go for aeration prior to any sort of treatment, that is sedimentation or filtration. Sedimentation is actually the process in which water is retained in a tank or basin so that the suspended particles will settle under the action of the gravity. And this is the tank that should be provided for all the water supply schemes. Those are Nala bases, because it is the tank that is responsible for maximum removal of the turbidity of the raw water. The design considerations that ought to be adapted as per the CPHO manual law, we should have a detention period of 3 to 4 hours for plain sedimentation, and if we are using alum, that is ferric sulfate, then it would be 2 to 2.5 meters. Plus, we should cross-check the dimensions that we arrive after assuming these 3 to 4 hours of detention period. We should cross-check it with the surface overflow rate. The surface overflow rate is nothing but discharge divided by BL, that is breadth and length, plan area of a sedimentation tank, and that should be more than or equal to 15 to 30 cubic meter per square per second. The aeration that is used mostly in the water treatment plant is the cascade aeration. This aeration is only used when water is having the content of either iron content or it is having the smell. So we go for the cascade aeration. However, in our rural areas, this aeration we don't resort to because we are not having that problem in our rural areas. In rural areas, we are having either the surface water available or the tube well that's not having this problem. So then we are having rapid sand and mixing. In rapid mixing, we are using an chemical that's called the alum, that is alum sulfate. The mechanism is that it mixes with the dirt and forms the flock and then settles down. So CPHU manual has given one thing that is specifically for these filtration, these sedimentation tanks, that is the inlet value. The inlet value of a sedimentation tank should be like that. The purpose is that we should not have a short circuiting of the water. The aim is that water should settle in a tank. Water should rest in a tank. If there is no proper arrangement of the incoming water, then there will be short circuiting. Water would come from one side and it would flow from the other side without having a retention time. So that's called the short circuiting. So the CPHU manual gives us clearly that we should have these type of the inlet arrangements available for our sedimentation tank. Next comes the filtration. So the filtration process, we may be having slow sand filtration, we may be having rapid sand filtration when the raw water is having less than 20 turbidity. We may go for the filtration that is slow sand, and when it is having more than 20, we can go for the rapid sand filtration. The filter problems are there. Formation of mud bubbles, cracking, clogging of filter media. That means the rapid sand filter is much more a skilled job. We have to do proper backwashing. We must do proper backwashing, and we must constantly see how this rapid sand is behaving. Whether the raw water that is coming into the filtration plant is actually getting reduced or not. If not, that means we may. The power consumption in a filtration plant, the filtration plant in the rural areas we use are 0.1 to 1 MGD or 1.5 MGD. So we are having some power consumption that is used, and for which we need the substation. We are having air blower, backwash pumps, bleaching pumps, which are having just 7 to 10 HP, 5 HP, alum mixing units. These are all required for efficient water supply, efficient treatment facility for water. Slow sand filtration, we are having, they require much more area, but their rate of filtration is very low. So we can have, if the area comes out to be 20, then we must have the number of beds. It is that how much number of beds we require. If the area is 20 square meters, then number of beds may be 2. Then if it is more than this, then number of beds may be 3. So slow sand, we have to make a choice. What should we adopt? Whether we go for the slow sand or the rapid sand. The slow sand has low filtration, but it may require more area. Rapid sand is compact, but it is having it is cycled. It's a cyclic job. It must have cyclic person available to operate. So this is the filtration plant the comparison between the two, the size of the filter bed, then filter media, then base material. Almost everything. The main difference between them is that the slow sand is required for smaller units, and the rapid sand is required for a larger unit. For suitability for slow sand, we go for smaller areas, smaller towns. For towns, we can go for this. For towns and cities, we go for the rapid sand. The cleaning method is that we scrap and remove the top method. However, in rapid sand, it is 24 hours washing. That almost 5% of the backwash water is used for backwashing. Thanks, sir. If there are any questions.
Hello. Hello, sir. This is Shaukat from PHA Groundwater, Srinagar. Sir, whatever the details you provide, it is good for the when we use a surface water. When it comes to the groundwater sources, we encounter the problems like having ammonical nitrate, high turbidities, and iron at sometimes. Do you have some designs in place for that?
If there is iron, usually the water would be of the metallic smell, and the metallic smell, that way we have to go for the aeration and with some pre-chlorination. So aeration, that's the cascading structure with pre-chlorination, should remove that, that.
Sir, that's fine, sir. I agree that when it comes to the handovering the scheme, when it comes to the handovering of the production wells to the territorial subdivisions, there is always a problem of having not handover and takeover problems there because of these things. Do you have already in your design the setup of removing that in process? That would ease our problems.
Quality of the water. You have to check the quality of the water. If the quality of the water says that it is iron and it is beyond the permissible limit, then you have to go. Simply you have to aerate it. Put more and more air, more and more oxygen, and then you can go for this. Or some special treatments are there like charcoal treatment, which I think. The Honorable has someday before given that we can go for the charcoal treatment. And we are having so many installations available where they are using it efficiently. For example, you may have visited this railway station Pampur. They were having the problem of iron. They are using that charcoal and then some, but they were not having the aeration available. So they were having charcoal, but the quality was very good as compared to the raw water. So depending upon the quantum of the iron that is present in the raw water, we may go for aeration, pre-chlorination, aeration, followed by sedimentation.
Sir, right, sir, right, sir. But the irony is this: the source of the water is decided earlier, and your design is already set up. What I mean to say is, the design for the water supply scheme is made earlier, rather than deciding the source.
That's the problem with groundwater only. But for the surface water, I think it is okay. Everything is okay. In
Sir,
valley,
I am
where
from the groundwater. That is why I am raising the question.
Yes. So I think that for this groundwater, there may be a problem of this iron content in central Srinagar Central Valley, but you may be having the problem of having the smell in northern belt. So I think that way you may have to go for some pilot project where you can take the water, get it tested, and then you can accordingly devise the treatment methodology.
Okay, thank you, sir.
So, excuse me, am I audible?
Yes, sir. Yes.
This is Anil Gupta, Executive Engineer, PHE, City 2. This is not, just about a little bit off-bit question because I'm serving in urban area, and nowadays there's everywhere the talk of 24/7 supply and this thing. So because if we are supplying some water to say 100 houses, and if we do it 24/7, so that can easily compensate 150 plus houses. So that will save a lot of water. So my question is whether you have an idea, and what are the material we are using for 24/7, and whether HDP or GI, which one will be better, and for which are the dias to be preferred, please.
Okay, sir. Sir, for providing 24 hours of supply to every consumer, that means you have to then bifurcate your area into the various grids or the zones. So that means you have to bifurcate that area so that if a particular quantum of water gets exceeded beyond the amount that is actually meant for that zone or for that area, the value should automatically shut. So that way you can provide 24/7 to all the households. So that's why we are having the automation and mechanization.
Of course, that is for that also. And the one plus point is that because you hello, am I audible? Hello.
Yes, sir.
Yeah. So one more thing is because the consumer will not be entitled for storage, and there will be meters around. So naturally, if I don't have that regular meter and this thing, then my tendency will be just to store it excessive, But when there are meters and there is 24/7, so certainly we are going to save a lot of water for that. And I think that's the future for, because we live in J&K UT and we have smart cities in Srinagar and Jammu. So when we talk about JJM and rural, we must talk about urban areas also. I think you agree with me.
Nawaz Saab, your mic is mute. Please unmute it.
Hello. I think Riaz Saab, my question was audible to the.
Yes, yes, it is audible, but Nawaz Saab's mic is mute. Nawaz Saab, please unmute your mic.
I'm
Okay,
just
okay.
waiting.
I'm
Yes,
audible now?
it is clear. Yes, yes.
Okay. So for providing, sir, 24/7 water supply to every household now depends on, we have to change the perception of that our water supply is for only 2 hours or 3 hours. What we have seen in rural areas that when we provide 24/7 water, it is possible, it is practically possible to provide 24/7 of water to every consumer. By way of, because everybody, every consumer, every household would be knowing that there will be water in my tap all the time. I would open my tap. So that way there won't be that rush of collecting the water from their taps. So there may be a problem initially, but when it is, I think, measures are taken, we can provide 24/7, and for going special, what I said, that value mechanization can provide.
Thank you. That is the future actually. Thank you so much.
Am I audible, Nawaz Saab?
Yes, sir. Yes.
Sir, in planning part, you have missed shifting of utilities. This is the main reason when the projects are getting delayed. Have you mentioned anywhere about this shifting of utilities in planning section?
I think that in shifting of utilities, yes, that is thing. But since in rural areas, maximum area falls that is not fully developed, so roads are not there. The utilities which we are having facing the resentment from our sister line department, that is only the R&D. So we don't have to shift many of the utilities, and sometimes some optical fiber cables are there, but those are very limited. That's how I have limited. I have not mentioned that thing in the presentation.
Please may consider.
Hello.
Yes, sir.
Hello. Sir, am I audible?
Yes, sir. Yes.
Sir, this is Vishal Pandita from PHE City Division 2 AEE.
Okay, sir.
Sir, my question is that salinity of groundwater, how it is being taken care of in urban areas, especially for groundwater supply schemes.
Salinity, definitely, that means there is concentration of more and more salt. So one simple and old method is that we should go for more and more of the purer water. That is, we have to go for dilution. So because
Sir,
we are not facing those. We are not.
My question, I am asking about salination, how it is being taken care of in case of groundwater supply schemes, because there is no means of filtration. Hello.
Yes.
Yes, sir.
I think we may have to see a proper solution for it. What, how can we have not encountered any problem, but in Jammu there is a problem of salinity, definitely. But in we are not having that problem here. So desalination plants we are having, but those are costly plants.
Rural areas, there will be no problem like such salinity. In urban areas, the percolation from ground surface, I mean, that will increase the salinity of water. That's what I'm asking for.
So as to remove the salt, which many countries are doing, but I don't know whether you are doing it or you have started it. So that is one of technique that is available.
Thank you, sir. Thank you very much, sir.
Hello, Nawaz Saab. Hello, Assalamu alaikum. Nawaz Saab.
Ji. Assalamu alaikum.
Assalamu alaikum. I am Farooq from Tangmarag, BID Tangmarag. Sir, This was the technical part of the presentation. Very important for us, sir. I think one thing we are missing, that is that we don't, during the execution of the works or the project as a whole, we don't aware the people about the quality or quantity of water we are providing to them, or we are supposed to provide them. Suppose we have to provide 50 LPCD to a consumer. When we provide them 50 LPCD, they feel as if, because they are habitual of having 24/7, maybe raw water in the earlier times, or they are habitual of having continuous water supply. So how can we address the issue of this awareness of the public about this water supply which we are providing, filtered or quality water, potable water? Number one. Number two, sir, most of the times whenever there are any sort of diseases or illnesses in a particular community, the medical fraternity attribute it sometimes to the water we are providing. So, but when we go to our reservoirs or the service level or consumer level, at some point of time, at some location, we collect a sample and we test it. We find out that it is okay. Its chlorination is done. Its quantum of chlorine is done. The parameters are in control. But in a specific pocket, there happens to be some sort of sickness or illness, and that is immediately being attributed to the water. Whereas this huge area is getting the water supply from the same reservoir or same supply line, 100 mm or 150 mm dia pipeline. So one particular pocket. So how, at what specific point shall we put up our checks or testing patterns so that we can isolate or we can identify exactly if that particular pocket has acquired that sickness because of water or not? Please. Thank you.
Regarding the awareness with regard to the availability of the water to a particular consumer, we are having in our plan, that is the IEC activity. There is fixed funds are made available for these IEC activities. So the purpose is that we should make aware the people about the quantum of the water they will be getting under these schemes. So it is 55. So that comes the awareness part. Regarding that breakout of the waterborne diseases, if it is an SR and it is an established fact that if at any point, if at any period of time, the consumer water is having a residual chlorine of 0.2 ppm in it, it is free from all the bacteria. So it is. We should not directly, in fact, some people attribute it directly to the filthy water or the dirty water that this disease has broke out. It is not only because of the water, it can be other hygiene mechanisms and it can be other things that are related to it. Hepatitis have different types of those are not always attributed to this water. So
yes,
in that case, we have to make sure that our treatment plants are functioning properly. We are having a good potable wholesome water available, and that there is chlorine present always. Then that can be avoided.
Yes, exactly, sir. And I believe that our pipe network that carries the pipe from the reservoir to along a length of 2 km, 3 km, we're having different distribution networks. That has to be very much leak proof. We have to ensure that has to be very leak proof so that there's no percolation of, because at some places our pipes are laid along those nalas or drains or etc. So we have to ensure that our connections are very leak proof, particularly.
Chlorine of 2 ppm should be at the consumer point. It should not be at the storage. So if we require at consumer point a residual chlorine of 0.2 ppm, the addition or the quantum of the bleaching that would be needed or the quantum of the chlorine gas that would be needed to be put into the reservoir would be more than this 0.2. Usually it is 3 to 5 ppm. So it should care of all those things that come in between from consumer point to the storage reservoir. That is the frustration, leakage, the other things. That's what we are having. So if we are not getting the residual chlorine, that means there is some problem in the distribution system. So that thing is it should be taken care of.
Okay, thank you very much, sir.
Good evening, Nawaz. Good evening, sir.
Sir. Good evening.
Am I audible?
Yes, sir. Yes, sir.
Sir, this is Satish Babur from IMSCD Jammu.
Right.
Sir, may I have permission to ask the question?
Yes, sir. Definitely.
Sir, in full presentation, you are taking the surface water.
Yes, sir.
We are taking the surface water from maybe whether it is from river, nala, seasonal nala, lake.
where there is a large variation in head and discharge during the year. Are you getting,
Right.
sir?
Right. Yes, sir. Yes, sir.
Can you elaborate where there is a large variation in head and discharge, how we can get the continuous
Yes.
water around the clock? Is there any design? Is there any IS?
During the lean discharge period, that means if we are having a pump designed for a particular water supply scheme,
Sir,
that means,
please, let me speak. I am talking about the civil design, where there is a large variation of head, let it be a 25 meter, 30 meter or 40 meter. How we can get the continuous water around the year?
one old method is that we should always divert the water during the lean discharge towards the intake works. That is one. The second thing is that the mechanical counterparts can do, they can install some draught pumps on the lower level with a flexible suction pipe so that their net positive suction head won't get exceeded in that pump, so they can use that and lift the water from that nala from the lowest level.
Is there, have you any design for an intake or jet well or the wet well or the dry well?
We're having such type of schemes already operational in Srinagar. We are having Gudranga, where we are having a proper design with these.
That is the dry well or the wet well?
Area, we are having the properly designed intake workers as well as these draught pumps, which take care during the period of the lean discharge. So during that period, we can lower those suction pipes, flexible suction pipes, and can lift the water.
Sir, that is a wet well or dry well?
It is open. It is open to. It is just a suction pipe with because these intake valves they usually also get dried up during the lean discharge period. So there won't be much water in it. So we resort to just a flexible suction pipe that will directly go into that pocket where there is water.
Sir, have you any design of intake which is submerged in the source?
Would be. I'll be seeing that with my mechanical counterpart where I have worked, and I will provide you, sir.
Sir, my next query is regarding the design of the pipe.
Okay, sir.
You have mentioned there is a minimum velocity of 0.6 meter per second.
Right, sir.
0.6. What is the optimum velocity in design?
So usually we can go up to 0.6 meter is the minimum velocity that is to be for these raw water mains. We can go up to 1.2, maximum 1.5 meters, because you have to see that it's not get exceeded beyond. If the velocity head is too much, then there may be problems with the overall pressure of the pipe. So we are having a pipe. It is having some limitations under limitations of the head under which it will be working. So that way we can limit it. In case of the gravity scheme,
it is same for every material or different for different materials?
What thing?
Sir, it should be same optimum velocity for different material, or velocity should be different for different material?
As per CPHU says that we have to provide a velocity of 0.6 for in the pipe. That is for every material.
Okay, sir. Thank you. Thanks a lot.
Sir, I have a submission. Yes. Sir, I am Ashfaq, Technical Officer, PHE Mechanical North. Sir, during your presentation, sir, the groundwater which we are harnessing, sir, if the groundwater has a ammonical nitrate, presence of an ammonical nitrate that is beyond the permissible limits, how it can be treated, sir? Is there any to bring it to the permissible limits within their tolerance limits? Sir, am I audible, sir?
Yes. Ammonical nitrogen problem
No,
is
sir.
Yes.
Okay, sir.
Ammonical nitrogen problem.
Sir,
is
you
the
are not
problem.
through light on ammonical nitrate treatment, sir.
Yes, sir.
No, sir.
Ammonical nitrogen problem is the problem with most of the wells in Kashmir Valley. So for ammonical nitrogen, usual method is that the chemists prefer is that we should go for the aeration. So aeration then followed by pre-chlorination and then storage we can greatly remove it. But we have to actually see how much is the remol and how much is the ammonium nitrogen that is present in it. There are limits that are as per the CPHU as well as for these as per the JGM guidelines, there are tolerance limits and the maximum limit is given in that. So if that limit is exceeding, then we have to go for these treatments like aeration, then pre-chlorination, aeration, and then sedimentation. But we have to actually see how much it gets removed. Only then we can design our an efficient water supply scheme.
Sir, can we bring it to the that permissible limits? What is the range for that, sir? Exactly, what is because the number of wells are getting rejected for the presence of the ammonium nitrate.
I think that a deeper study needs to be done in this case because I have not seen any of the well here in my jurisdiction and in the where I have worked where the ammonium nitrogen is too much. So I think that we have to go for, I may request Riyaz sir that we must go for a deeper study for this ammonium nitrogen removal, and so that we may have a efficient water supply scheme. As the groundwater people are mostly digging the wells, but when there is the ammonium nitrogen, then this quality issue, then mechanical people don't take it. So we may have to go for a deeper study.
Okay, sir. Okay, sir.
Good afternoon, sir. Good afternoon, sir.
Good afternoon.
Sir, this is Iqbal from PHE Mechanical North Sopor. Sir, in your second slide, one of the parameters mentioned was trends in future demand. My question is, what is the method that has been followed to calculate this future demand? And have we incorporated this future demand into our design to decide the SR capacity and the discharge required? Because we see if you are planning over a period of 20 to 30 years to provide water to the people, I think what we are seeing is in number of tube wells, we have recently commissioned 2 to 3 schemes, and in a period of say 4 to 5 months of the operation of the schemes, what I feel is that there is still the scarcity of water, and in those areas people complain that we are not getting adequate supply of water. Can you please elaborate on this future demand trends? What method have you followed, and has it been incorporated in deciding the SR capacity and discharge required? Thank you, sir. Please.
Okay, sir. But for determining actually for the design of the SR, we have to first calculate the value of the discharge, that is value of the water that is required. So for that, we will require the one thing is that population. Now, once we know the population, that is a fixed population that is present in a particular locality, then we have to go for the future trends. Future trends mean that we don't have to go for only the birth and the death ratio of the people in that particular area, but we have to see how much is the urbanization and how much is the migration of the people. In rural areas, there have been the migration of the people much more in some hamlets of the ST people. Likewise, in cities, there is migration of the people. So that thing should be taken into account, and that have been taken into account in JGM water supply schemes for calculating the value of the total water requirement and the SR capacity.
Sir, actually, I want to know there are various methods to predict future demand. They are regression method, then we have linear method, then we have exponential method. Can you recall what is the exact method that has been followed?
Increase method, incremental increase, then geometrical increase, decreasing rate of growth method, and graphical method. All these methods we have having available with us. So we can take any of the methods which can give us a conservative result, then we can adopt that in our design of the scheme.
Thank you, sir. Thank you, sir. Thank you very much.
Thank you, Nawaz, for the nice presentation. Manoj sir, the Chief Engineer, INFC Jammu, may we close today's session now?
Riyaz sahab, I have a question. Can I ask?
Hi, Adil sahab.
Hello.
Yes, Adil sahab.
Good evening, Nawaz sahab. Hello, am I audible?
Yes, you are audible.
Nawasa, first of all, I congratulate you that your presentation was very precise and to the point. Now, coming on to question, during your presentation, you said that slow sand filtration plant needs skilled workers and rapid sand filtration plant doesn't. But I don't feel so. I think rapid sand filtration plant needs more
I have said
skilled.
that, then I take that statement back. In fact, slow sand are very easy to operate than rapid sand.
Yes. So, Nawasa, what do you feel? Can you please clarify? I think rapid sand filtration plants needs more skilled workers because it's a very complex structure.
Although needing more skilled workers, but I think that they are more operational today in most of the schemes because we are having a regular washing of these plants as compared to the slow sand. Slow sand plants, although they don't require much of this skilled labor available or skilled manpower available. But with the passage of time, so there is some silt that gets deposited in it and that won't get removed at times. So that way we are having the problem. Further, we don't have the in slow sand when there is deposition of silt at the bottom. That means then the people may resort to bypassing it and doing something. That's why rapid sand are more, although they are having more capital cost, but we should prefer the rapid sand.
Fine, sir. Agreed. One more point, sir. During elaboration of these use of DI pipes, you said at a point that you compared lead coke joint with gasket joint. That is also called Titan joint. What I want to point is that I strongly feel that Titan joint, that is gasket joint, is very much efficient, but we are forced to use lead coke type joints during providing of MS fittings because the problem is that we have only fixed types of fittings available in DI pipes of certain degrees like 22 degrees, 90 degrees, 60 degrees. That is the point. That is the problem with DI pipes, that their fittings come into in some angles only. That is why we are forced to use these MS fittings and to provide lead joints further. Do you agree with this?
Yes, sir, that is true. But those fittings, those joints, or the connection that you may be needing at a particular supply, maybe 2 or 3 connections. But if the pipe is 2 kilometers, 3 kilometers, and you have only done this in DI pipe, and then there are 2 or 3 connections or 2 or 3 sluice wells that you want to insert in between. After some time, or as per your need, then you want to go for the lead coke, you can do it.
Sir, I agree with it, but what I feel, I don't find past some years, I don't find a proper solution to neglect these MS fittings, to neglect these lead joints. I think there should be some work should be done to find a solution of it, because in an entire network, the weak points are where these lead coke joints exist, especially in trunk main pipelines. But I have also worked on it, but I don't feel that there is any proper solution to neglect these lead coke joints. If you have any, kindly comment on it.
If a pipe of certain diameter is available and you want to insert a sluice value in it, then if you are having the gasket of that pipe available and with proper the collar of the MS available with you, you can insert that gasket into that. But the leakage at that point you have to check. So in that case, to be a leak proof, you usually resort to this sort of thing, that is the lead caulking.
Yes.
But if I think that if the MS joint is made, I think that the MS pipe special is made in such a way that a proper collar is there and the gasket is available with you. You can easily insert a sluice value, or you can easily take a connection from an existing line without involving lead caulking.
Fine, sir. I was just asking that is there any way that we can completely avoid these lead coke joints? Anyway, sir, thank you. Thank you.
May I add to these fittings? One way to avoid these MS fittings is to use more and more DI fittings. I think we have DI every kind available nowadays. So before planning any pipeline, we should make available all those fittings which are available in DI. That is one of the solutions to avoid these MS fittings.
Point taken, sir. Point taken.
I think now enough questions have been asked, and I'm thankful to all who have participated in this question answer session. Both the PPTs
Sir,
were
excuse me, sir.
very.
Sir, I have a submission, sir.
Okay.
The technical officer, PHE Mechanical North, sir. Nawaz, sir.
Yes.
Sir, I have a
Yes.
question regarding this filtration plant.
Alaikum.
The capacity of the filtration plant. We are
Ishfaq
having the
sir, it
pumping
is
capacity
closing now.
at
Ishfaq sir,
levels
please.
only. Sir, we are having pumping capacity.
Manoj sir, request to please continue.
Okay. So I was just informing everyone that the session was extremely good. It was a very good session, and everyone participated with full zeal and asked the questions to the presenters. And the PPTs were also very good, very well done, and it is very appreciable. And we must close now this session with I'm grateful to every participant who has contributed towards the success of this series number 10. And I hope that for the next series also the engineers will contribute voluntarily, and we expect that the PPTs shall be submitted by Monday. Thank you all. So we must close this session. Okay.